Our universe is a place of constant motion. From the tiniest atoms to the largest galaxies, everything is moving. Understanding these movements is a fundamental part of physics. Sir Isaac Newton, a brilliant scientist, developed laws to explain how objects move. His first law of motion, also known as the Law of Inertia, is our focus today. This law helps us understand why things move the way they do. The Law of Inertia is a fundamental principle in physics. It helps us make sense of the world around us. It governs the motion of objects big and small. Newton's first law of motion states that an object at rest will stay at rest. An object in motion will continue moving at the same speed and in the same direction. This continues unless acted upon by an unbalanced force. Let's break down this law. An object at rest is not moving. Motion means the object is changing its position. Constant velocity means the object is moving at the same speed and in the same direction. An unbalanced force is a push or pull that changes an object's motion. Inertia is the tendency of an object to resist changes in its state of motion. Objects like to keep doing what they're already doing. A heavier object has more inertia than a lighter object. This means it's harder to get a heavier object moving. It's also harder to stop it once it's in motion. Imagine trying to push a car. A small car has less inertia, so it's easier to push. A larger, heavier car has more inertia. It takes much more force to get it moving. Mass is the amount of matter in an object. Inertia is directly related to mass. The more massive an object, the greater its inertia. This means it's harder to change the object's motion. Consider a bowling ball and a tennis ball. The bowling ball has more mass and therefore more inertia than the tennis ball. This is why it's harder to throw or stop a bowling ball compared to a tennis ball. Section 5. Everyday examples: inertia in action. We see examples of inertia every day. When you're on a bus and it suddenly stops, you jerk forward. This is your body's inertia trying to keep you moving at the same speed the bus was. When you kick a soccer ball, it eventually slows down and stops because of forces like friction and air resistance. These forces act against the ball's inertia, eventually bringing it to a stop. A book resting on a table stays put because its inertia keeps it at rest. No unbalanced forces are acting on it. Section 6. The skateboarder's tale. A case of inertia. Imagine a skateboarder rolling along a smooth, flat surface. The skateboarder will continue moving at the same speed and in the same direction. This is because of inertia. The skateboarder will only slow down or change direction if acted upon by an unbalanced force. This force could be friction from the wheels, air resistance, or the skateboarder pushing off the ground. The greater the force applied, the greater the change in the skateboarder's motion. Section 7. Celestial harmony, inertia in space. Inertia is a fundamental concept in physics, and its effects are magnified in the vast, frictionless environment of space. Inertia plays a crucial role in the vast expanse of space. It is the property of matter that keeps objects in motion or at rest until acted upon by an external force. Consider the International Space Station, or ISS, orbiting Earth. This marvel of human engineering is a perfect example of inertia in action. The ISS is constantly in motion, yet it appears to effortlessly glide through space. This seemingly effortless motion is a direct result of inertia. This is due to inertia. In the microgravity environment of space, objects do not experience the same resistance they would on Earth. Once an object is in motion in the vacuum of space, it will continue in a straight line at a constant speed unless acted upon by an outside force. This principle is crucial for the movement of spacecraft and satellites. In the case of the ISS, Earth's gravity acts as that force, pulling the station towards it. This gravitational pull is what keeps the ISS in its orbit around our planet. However, the ISS's forward motion, combined with Earth's curvature, creates a delicate balance, keeping it in orbit. This balance is a dance of forces where inertia and gravity work together to maintain the station's path around Earth. Without this balance, the ISS would either drift off into space or be pulled back to the planet's surface. Inside the ISS, astronauts experience microgravity, which allows them to float and conduct experiments that are impossible on Earth. This environment is a direct result of the station's constant freefall around Earth, another manifestation of inertia in space. The trajectory of the ISS is carefully calculated to ensure it remains in this delicate balance. Engineers and scientists continuously monitor and adjust its path to account for any external forces that might disrupt its orbit. Inertia in space is not just a theoretical concept, it is a practical reality that governs the movement of all celestial bodies and human-made objects. Understanding and harnessing this principle allows us to explore and utilize space in ways that were once thought impossible. Section 8. Inertia's role in transportation from cars to rockets. In this section, we will explore how the principle of inertia is not only crucial for everyday vehicles like cars, but also for advanced technology such as rockets. The principle of inertia is fundamental to how we design and operate vehicles. Engineers and designers take inertia into account to ensure safety and efficiency in transportation. When a car accelerates, you feel a force pushing you back into your seat. This sensation is a direct result of inertia, which resists the change in motion. This is your inertia resisting the change in motion. The faster the car accelerates, the stronger this force feels, making it a key consideration in vehicle design. Similarly, when a car brakes, you feel a force pushing you forward. This is again inertia at work, resisting the sudden change in speed. Rockets launching into space also rely on inertia. The principles that apply to cars on the road are magnified when it comes to rockets. The powerful engines of a rocket provide a tremendous upward force. This force must be strong enough to overcome the rocket's inertia and Earth's gravitational pull. This force overcomes Earth's gravitational pull, propelling the rocket upward. As the rocket ascends, it must continuously fight against inertia and gravity. Once the rocket escapes Earth's atmosphere and shuts off its engines, it continues to travel through space due to inertia. In the vacuum of space, with no air resistance, the rocket can maintain its velocity with minimal effort, showcasing the enduring power of inertia in motion. Section 9. Applications of inertia, equilibrium, and beyond. Understanding inertia is crucial in many fields. Engineers use it to design safer cars with features like seatbelts and airbags. These safety features help counteract the effects of inertia during sudden stops or collisions. The concept of equilibrium, where an object is at rest or moving at a constant velocity, is also rooted in inertia. For an object to be in equilibrium, the net force acting on it must be zero. This means all forces acting on the object are balanced, and there is no unbalanced force to cause a change in motion. Section 10. Newton's legacy, a foundation of physics. Newton's first law of motion is a cornerstone of classical mechanics. It laid the foundation for understanding how forces interact with objects to cause motion. This law is not just a theoretical concept, it's a fundamental principle that governs the physical world around us. From the motion of planets to the design of vehicles, Newton's first law has far-reaching implications. It helps us understand the universe on both macroscopic and microscopic scales. Section 11. Conclusion. Inertia's enduring impact. Inertia is a fundamental concept that governs the motion of objects. It is a principle that we encounter in our daily lives, often without even realizing it. Whether it's the cars moving on a busy highway, people walking in a park, or a river flowing steadily, inertia is at play. It's the tendency of an object to resist changes in its state of motion. For instance, a runner slowing down after a sprint, a ball rolling to a stop, or a pendulum coming to rest, all illustrate inertia in action. These everyday examples help us understand how inertia influences the world around us. Newton's first law of motion elegantly encapsulates this principle. This law, often referred to as the law of inertia, is a cornerstone of classical mechanics. It provides a clear and concise explanation of how objects behave when forces are applied or removed. This law states that an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and in the same direction, unless acted upon by an unbalanced force. This means that without external forces, the natural state of an object is to maintain its current motion, whether that be at rest or moving uniformly. Understanding inertia is essential in various fields, from designing safer vehicles to comprehending the movements of celestial bodies. Engineers use the principles of inertia to create safety features in cars, ensuring that passengers are protected during sudden stops or collisions. Astronomers rely on inertia to predict the orbits of planets and the behavior of stars. As we continue to explore the universe and unravel its mysteries, Newton's first law of motion will remain a guiding principle, reminding us that objects in motion tend to stay in motion, a testament to the elegance and power of the laws that govern our universe. This principle not only helps us understand the physical world, but also inspires us to look deeper into the forces that shape our reality. From the smallest particles to the largest galaxies, inertia plays a crucial role in the grand tapestry of the cosmos.